Hello, I'm Ronan, and I suppose we get going. So usually when I talk about what I do, I talk a lot, and too much, if you ask my friend Etna here. And she's a journalist, and she's always telling me that I'm boring people, so she kind of always interjects with a kind of one-line summary. And she tells people that basically I put pencils into soap to save on your petrol. And that sounds a bit ridiculous, but I actually couldn't come up with anything better myself, you know, it's pretty good. So I'm just going to elaborate on it a bit. So when she talks about pencils, what she's actually talking about are the two-dimensional materials that I work with. And the most common of which would be graphene. Now graphene is a sheet of carbon atoms held together in this kind of chicken wire structure. And even though it's thousands of atoms long and thousands of atoms wide, it's only one atom thick, hence we call it two-dimensional. Now it exists in nature stacked in graphite, which is the stuff on the end of your pencil that Etna's talking about. And besides graphene, a lot of other layered materials also exist. And they all have wonderful electrical and physical properties, but they're only really useful to us if we can separate them out into their individual sheets. So how do we do that? How do you get it out of the pencil? So the original method uses Scotch tape, and all they do is they peel the sheets away from the surface. And while that works, it's very laborious and it's not very scalable. So to tackle that problem, I put the materials in soap and water, and then I blast them with sonic energy. And what that does is it breaks the sheets apart. And what the soap then does is that it stops them from sticking back together. Now, it's able to do this because of its structure. So you can divide soap into two parts, one that loves water and one that hates water. So basically the part that loves water, the part that hates water, that sticks to the sheet because the sheet hates water too. And then the part that loves water, that sticks out into the liquid and acts as a kind of life vest, which stops the sheets from sticking back together. And the result is that we get nice stable dispersions of these 2D materials, like the one you see here. So now that we've put, the pencils in the soap, how do we save on petrol? Well, if you've ever driven your car, you'll notice that the engine gets very, very hot. And this heat is just energy wasted. So wouldn't it be great if we could recycle some of that heat? Now, that's what thermoelectric devices do. They convert waste heat into usable electricity. But to do that, they need two properties. The first is they must conduct electricity well, and the second is that they must create a voltage when heated. Now, the catch-22 about most of these materials is that ones that create this voltage don't really conduct electricity very well, and vice versa. But now that we have these dispersions of different 2D materials, we can mix two together, each with the property that we want, to make hybrid films. And these hybrid films combine both properties. And so we're able to make thermoelectric devices that are both good conductors and that create this voltage when heated. So it's not really so ridiculous for Etna to say that I put pencils in fairy liquid to save on petrol. Thank you very much.